I'm going to continue from where I left. So we had this 2 times the integral of 1 over t plus 1 whole squared plus 1. And I was saying that this is basically the derivative, or this looks like the derivative of the tan inverse of x. But here we don't have x. In x's place we have t plus 1. So this will be basically the this is the derivative of tan inverse of t plus 1, and the whole integral, the whole answer will be 2 times tan inverse of t plus 1. So basically we were integrating this these two things, and this is easy to integrate because um, its derivative is written in the numerator. So this has just the its integral is just natural log of t square plus 2t plus 2, and we have found the integral of this thing, that is 2 times tan inverse of t plus 1. So this is what I was saying, that this thing has the integral 2 times tan inverse of t plus 1, and the whole integral of this thing, which we wanted to find, is half times natural log of t square plus 2t plus 2 plus 2 times tan inverse of t plus 1. So this is the integral of this thing. And if you remember, we had a similar looking expression, uh, which whose anti derivative we also need to find, because our our required integral was a combination of these two integral of combination of these two integrals. So the next expression, which we need to find the integral of, was 2 minus t over t square minus 2t plus 2. And the problem with this expression is that the derivative of the denominator is basically 2t minus 2, but we have minus t plus 2 written in the numerator, and we need to express this 2 minus t in such a form that we are able to that we are easily able to integrate. So I've written this 2 minus t as minus t plus 2, simply rearranged it, and then I've written this minus t plus 2 in the form of 2t minus 2 over minus 2 minus 2 over minus 2. And I told you before that uh, we basically used the derivative of the denominator, which in this case is 2t minus 2, and adjust the other things around that, so we get the numerator part. So I've used this 2t minus 2 and written minus 2 and minus 2 over minus 2 alongside it. So it when it's solved, it gives us minus t plus 2. And we also need to verify it whether this is correct. So when we take the LCM, we have minus 2 as LCM, and in the numerator we have 2t minus 4, because 2t minus 2 minus 2 minus 2, it becomes 2t minus 4. So if this numerator can be written um, as a combination of terms, so this 2t and 4 can be separated. So this will become 2t over minus 2, and this will become minus 4 over minus 2. So these two 2's basically cancel out, and we are left with minus t plus 2. So as I said, we need to write this uh, what we had here, minus t plus 2, I guess. Yeah, this minus t, we need to write this minus t plus 2 as the combination of these two fractions, and so that we can easily integrate. uh, So I've written that minus t plus 2 in the form of 2t minus 2 over minus 2 times t square minus 2t plus 2 over 2 times t square minus t plus 2 minus 2t plus 2. So we can see that in the first fraction we can uh, what this re, uh, what this has done for us is that we now have the derivative of the denominator in the numerator, because the derivative of denominator is 2t minus 2, which we have in the numerator now. So but we need to find the integral of this thing, 2 over 2 times t square minus 2t plus 2. So um 2 over 2 times t square minus 2t plus 2 minus, I've just rearranged it. This was a positive term, so I've written it first. So 2 over 2 times t square minus 2t plus 2, and I've written minus 1 over 2. This negative sign goes to the numerator, minus 1 over 2, and I have taken it outside, and times this 2t minus 2 over t square minus 2t plus 2. So the integral of this thing is simple, minus 1 over 2 times 1 over 2 times the natural log of this denominator, because its derivative is written in the numerator. So this is what I was saying, that we need to find the integral of this term, because uh, we don't have its we don't have the derivative of the denominator it in the numerator or something, or we don't know how to, or we don't know simply by seeing it that how will we integrate this thing, or uh, so I'm taking this 1 over 2 outside the integral, and we are left with 2 times integral of 2 over 2 t square minus 2t plus 2 dt. So 2 over t square minus 2t plus 2. We get the hint by seeing the denominator, how to integrate this thing, because we have t square minus 2t plus 2, and it kind of resembles the formula of a square minus 2ab plus b square. So I've taken this 2 outside the integral, and we are left with 1 over t square minus 2t plus 2, and we need to integrate this. So as I told you that this kind of resembles a minus b whole squared formula. So I'm writing in this in the form of that formula. So we have t square, which can be considered as a square of that formula, minus 2 a is t, and b is to be decided. And so we need to think that what b will give us minus 2t here. So b has to be 1. To complete the formula, we need to have the b square term as well. So plus b square, b is 1, so 1 squared, and we have 2 here. We don't have we have 2 here, so we need to make this as 2. So 1 squared is 1, so we need to add 1 here. So it gives us the 2 written in this step. So we have these 3 terms which give us the formula for a minus b whole squared. So we have 2 times integral of 1 over t minus 1 whole squared plus 1, and we are integrating this with respect to t, and 2 times integral of 1 over 1 plus t minus 1 whole squared, and we are integrating this with respect to t. So this is again the same form. We have 1 plus x, or in place of x we have t minus 1 here. So written in the x squared written in the form written here, and this kind of resembles, not exactly, this is not exactly the derivative of tan inverse of x, but it kind of resembles the derivative of tan inverse of x, but in place of x we have t minus 1 here. So this will be the derivative of tan inverse of t minus 1. So this is basically the integral of this thing. So 2 times tan inverse of t minus 1 is the integral, and so we wanted to find the integral of this thing, 2 minus t over t square minus 2t plus 2. That is why we wrote this 2 minus t in a form which we could integrate. And so the integral of this thing is 1 over 2 times tan inverse of t minus 1 minus 1 over 2 times natural log of t square minus 2t plus 2. So we are left with tan inverse of t minus 1 minus 1 over 2 natural log of t square minus 2t plus 2. But if you remember, this basically our original integral was basically the combination of the integral of this thing and the previous similar looking expression. So the final answer will be 1 over 8 times the integral of those two expressions, this expression and the previous one. So 1 over 8 times 1 over 2 natural log of t squared plus 2t plus 2 plus tan inverse of t plus 1 plus tan inverse of t minus 1 minus 1 over 2 natural log of t squared plus 2t plus 2. So this is basically the final result for the integral. So 1 over 16 times natural log of t squared plus 2t plus 2 plus 1 over 8 tan inverse of t plus 1 plus 1 over 8 tan inverse of t minus 1 minus 1 over 16 natural log of t square minus 2t plus 2 plus the constant of integration.